Hi, Calc Peeps. Today we're going to talk about the trapezoidal approximation for area, and we are going to start with this as example 1. Consider the region bounded by x equals 0, x equals 12, y equals 0, and the function f of x equals negative x squared plus 12x plus 4. We are going to start by graphing the region that they give us, and we go from 0 to 12 in x. And I'm going to go ahead and say let's use 4 subdivisions, 4 equal subdivisions. So that would break us up if we're going from 0 to 12. Then that will cause us to look at 3, 6, 9, and 12. All right, so let's graph this based on what we have right here. So I'm going to start by plugging in 0, and when I plug in 0, we get 4. So that's going to be there. And 6 would give us about 40, so that would be our maximum. So if I were to graph this, it would look something like that. Okay? Now we're going to break this up using 4 equal trapezoids because trapezoidal approximation, go figure. So I'm going to divide each section from the x value provided, and I know you are loving the super straight lines that I have going on right now. And each of these from endpoint to endpoint is going to make a trapezoid. So all of these 4 trapezoids. Now, you should remember from us dealing with trapezoids before that the area of a trapezoid equals 1/2 base 1 plus base 2 times our height. And if we do this for our 4 trapezoids, we're going to do 1/2 base 1 plus base 2 plus the height 4 times. So I'll say plus dot dot dot. So let's take a look at what we have going on here. Our area for our 4 trapezoids right here is going to be 1/2. Well, what is the length of our bases? Okay. Well, our first base is going to be f of 0, and we plug in 0, we got 4. And then it's going to be f of 3, and when you plug in 3, we get 31. The base would be the distance from 0 to 3, which is 3. That's trapezoid number 1. Trapezoid number 2, 1/2. Again, f of 3 is base 1 now, so that would be 31. F of 6, which is 40, and again, our height, which is 3. Go again for trapezoid number 3. 40, 31, 3, and I'll have to write our 4th trapezoid down here. 31, 4, and again our height of 3. Just to remind you where everything was coming from. This was f of 0 plus f of 3. That's how we got base 1 and base 2. This was f of 3 and f of 6. This was f of 6 and f of 9 added together, and this was f of 9 and f of 12. Very similar to what we were doing with LRAM, RRAM, and MRAM. Okay, so let's keep going and adding these together. So our area equals, well, since they all have this 1/2 and this 3, they all have 1/2 and 3. I'm actually going to factor that out to make it easier. So now I'm looking at 3/2 times, okay, now I can say, well, everything else I can add together if I wanted to. 4 plus 31 plus 31 plus 40 plus 40 plus 31 plus 31 plus 4. Or if you notice, I could say that that is just 3/2 times 4 plus, oh look, 31 shows up twice here in order, plus 40 shows up twice here in order. 31 shows up again. And then 4 is on its own. Continuing on to the next page, that would be my area of that trapezoid equals 4. Sorry, forgot to write 3/2. Erase. 3/2 times 4 plus, when you multiply everything times 2, I have that 62. Can I write 62? Sorry, it has to be below this drop-down menu on my iPad. That's not liking as I get close to it. Okay, so now let's add this all up. That's 3/2 times, add everything together, 212. Multiply that by 3/2 and you get 318. We would have units squared. So now my question to you, is this area under or over the true area? Well, because we actually know the function, we can check using antiderivatives. Because we can say the integral from 0 to 12 of negative x squared plus 12x plus 4 dx, you would say, all right, what's the antiderivative of that? So you're thinking, what function yields negative x squared plus 12x plus 4 as its derivative? And that would be negative 1/3 x cubed plus 6x squared plus 4x. That's definitely supposed to be a plus sign. I don't know why it looks like an and. Evaluated from 0 to 12. And when you plug in 12 and plug in 0, you're going to get that 336 is the actual area, so you can see that we are just slightly under. All right, so let's talk about what this means for the trapezoidal rule in general. All right, we have our graph. And we are going to have some value A, some value B, and some graph that goes between A and B. Okay? If we divide it, so we'll say let's divide into n equal subdivisions. So when we are dividing by n subdivisions, that means we're going to have trapezoids that'll go in here. So that could be like delta x of 1, delta x of 2. When I'm saying delta x, I mean for my width. So I have all of these trapezoids forming in here, okay, where I have delta x1 right there, delta x2, and so on and so forth. So what's happening is the height of our trapezoid, okay, because remember, the y values make our two bases. The height is the change in x. So we refer to that as delta x, and that's actually the distance from A to B, or B minus A, divided by how many subdivisions you make. So we have the area of our trapezoid, 1/2 B minus A over N. That represents our height. Okay? And then we have f of A plus 2f of x of 1 plus 2f of x sub 2, etc. and so forth until you get to f of B. Closing that off. Okay, you could also think about it in terms of it's 1/2 your change in x, remember that is our height, of f of A plus 2f of x1 plus 2f of x sub 2, so on and so forth until you get to f of b. That's the trapezoidal rule. What you need to look at is the fact that each height, and let me grab a different color here so you can see, but this height f of a is used only once, and f of b is used only once. Every other height is used twice. Right here, okay, f of x of 1, that's used as the left side of trapezoid 1, the left side of trapezoid 2, the right side of trapezoid 1, and so on. That's why it's used twice. So this is the trapezoidal rule that you need to know. The absolute left and right, f of a and f of b, are used only once. All of the other y values are used twice. Let's knock out one more example. So we want to find the area under the curve y equals sine x from 0 to pi using the trapezoidal rule with 4 equal subintervals. So we're going to say our area with our trapezoid is 1/2 b minus a over n. So that's pi minus 0 over 4. And now, if we're going from 0 to pi with 4 subintervals, that's going to be, what did I even write right there? Sorry about that. F of 0 is going to be used once, and then we're going to use f of pi. And if we're breaking that down into 4, that means I'm going to use pi over 4 twice. I'm going to use pi over 2 twice. I'm going to use 3 pi over 4 twice, and pi only once. Sorry for running out of room. I have ridiculously large handwriting. Going again. Okay, pi over 4 times 1/2. I'm going to write that as pi over 8. Oh, shoot. Sorry you have to hear that bell. Deal with it. Here we go. F of 0. Hey, what's the sign of 0? That's 0. Plus 2 times f of pi over 4. What's the sign of pi over 4? That's 1 over root 2. Plus, what's the sign of pi over 2? 1. So that's 2 times 1 plus 2 times sine of 3 pi over 4 is also 1 over root 2. And sine of pi is 0. So this becomes pi over 8 times 2 over root 2 plus 2 over root 2. Or you could say pi over 8 times 4 over root 2 plus 2. And if you wanted to, you could approximate that on your calculator and know that it's 1.896. You should know or recognize that this is slightly under because when we've actually found y equals sine x before in our notes multiple times, and it's actually 2. But that's the trapezoidal rule. If you have questions, bring them to class. We're going to go over this more so after your quiz next time. Have a great day, guys.